Hi friends, are you preparing for exams, maths exams, CSEC or IGCSE examination? If you are preparing for exams, your maths exam, and you need help, then this lesson is for you. This second foundation class will cover multiples and factors. Just a summary of what I intend to cover today. A bit of multiples, factors, prime factors, all factors, highest common factor, and lowest common factor. In fact, lowest common multiple that should be. Oops. Let's correct that. Lowest common multiple. Yep, sorry about that. Yes. All right, so let's see. Let's dive into this. I think we have to correct that somewhere else too because I did duplicate that. All right, so yes, anyhow, when I see it, when we see it right here, I think, yeah. So let's go over to here, and I have to correct it here. So let me just correct it quickly, and then we can continue. Common multiple. Correct. So let's do this now. Let's look at multiples. I'll go into my notebook. All right, this is from the last class. We don't need that. We can do this. All right. Can we zoom this a little more? Yep, that's good. And so now let's look at multiples. That's quite easy. If you have, we all know that multiples, you multiply. So multiples of 2 would be 2, 4, 6, 8, 10, 12, etc. And multiples of 3 would be 3, 6, 9, 12, 15, etc. Okay, let's do one more. Multiples of 4, 8, 12, 16, 20, 24, etc. All right, so I think generally everybody got a good idea what are multiples. Now, what are factors? So multiple. And by the way, do take the opportunity to go do a search in Google and check the definition for multiples, and you maybe can write it down so that you will remember what is a multiple. Of course, it's quite easy for you to give examples, but what about a definition? Go check it out, and if you'd like, you can also share it for your colleagues in the comments below. All right, so feel free to contribute to the class by putting the definition for multiples. All right, how about factors? Now factors, let's look at say a number like 24. 24 got nice factors. In fact, before we do 24, why don't we do 12? So let's look at factors of 12. factors of 12, for us to get the factors of 12, what we do, we tend to ask ourselves what can go into 12, right? And when the numbers are small like this, like in this instance 12, it's quite easy. We know 2 can go into 12. We know 3 can go into 12 without any remainder. We know 4 can go into 12. And we know 6 can go into 12, meaning 2 into 12 will be 6, 3 into 12 will be 4, 4 into 12 will be 3, 6 into 12 will be 2. So these are all factors of 12, right? Now what I found is that many high school students, fifth formers, grade 10, grade 11, even grade 12, they can find factors for small numbers. But what happens when they get really big numbers? And this idea is very, very important for your exam. And notice this is a revision kind of foundation class for CSEC, as well as IGCSE examination. These exams got factorization, all right? And I know you guys will want to hear about factorization and not factors here. But if you don't know a method and you don't understand to find factors, you don't know a method to find factors, when you reach exam class, maths becomes difficult, factorization becomes difficult. So mind you, this is an important aspect, and that is why I'm doing this revision class, right? So make sure you learn how to do factorization. Factors. When you know to find factors, of course, you can apply the same idea in factorization, and you'll see how later in more advanced class. So let's look at factors. How do we find factors? There's a nice technique that they use. Before we use that technique, we need to look at something else. We need to know what's prime numbers and what is a non-prime number. And basically, I'd like to go through prime. Did I put that there? No, I didn't put it in my list, but we'll still go through them. Prime numbers. So in fact, I can write it out nicely. Prime numbers, right? What are prime numbers? So again, I will give some examples. Check a nice definition for prime numbers. Do some research and write down a definition for prime numbers. So example for prime numbers, you got 2, 3, 5, 7. 9 is not a prime number because 3 can go into 9. 11 is a prime number. 13. 15 is not a prime number because 5 can go into 15. After 13 we'll have 17, and then notice 19 is a prime number, but 21 is not a prime number because 3 can go into 21, as well as 7. And then 25, 20, 21, 23 is a prime number. 25 is not a prime number, obviously. 27 also, because 3 and 9 can go into 27. 31 is a prime number. 33 is not a prime number because 11 and 3 can go into 33. 35 is not a prime number. 37 is a prime number. 41 is a prime number. 47, oops, 47 is a prime number, 49 is not a prime number. And what about 51? Tell me, is 51 a prime number or not a prime number? Let's see who will get it correct. Tell me in the comments if 51 is a prime number or is not a prime number. All right, so let's move on. Now, why we introduce prime? Why did I introduce prime number just before factors? Because we will use these prime numbers to decompose a number into factors, and we use the prime numbers to decompose. So I'll show you the process here. So let's do 12 and let's see if we'll get back 12. Let's take 12 and decompose it into all its factors. So you have 12, and let's decompose 12 into all its factors. So let's start with this lowest prime factor and prime number, which is 2. Can 2 go into 12? Yes. So we say 2 into 12 will be 6. Then we say, what can go into 6? Again, can 2 go into 6? Yes. So we go 2 into 6 would be 3. What can go into 3? Obviously 3, which is a prime number here, and you get 1. And so you will see that 12 is equal to 2 times 2 times 3. And if you write this like this, 2 to the 2 times 3, what you're writing here, these two numbers here, they are prime factors. They are prime factors. Why they are prime factors? Because 2 is a prime number and it is also a factor of 12. 3 is a prime number and it's also a factor of 12. And therefore, the prime factors of 12 will be what? 2 and 3. So this is how you find what? Prime factors. So we just look at prime numbers. Now we are looking at what? Prime factors. All right. Our next step now is to, let's do one more example, and let's choose a big number. How about a number like 72? Let's do a big number. Find a, right? Yep. 72. 2 can go into 72. That will be 36. 2 can go into 36. And that will be what? 18. 2 can go into 18. Will be 9. 3 can go into 9. Will be 3. And then, oops, all right. And then 3 into 3 will be 1. So we'll end up with 72 is equal to 2 times 2 times 2 times 3 times 3. And of course, you can write this again as 2 to the 3 times 3 to the 2. And the prime factors of 72 will be 2 and 3. Prime factors of 72 will be 2 and 3. Factors will be prime factors again. So these are prime factors. Alright, so far what we did, we found multiples, which is quite easy. We identify prime numbers less than 51, and of course you will tell me whether prime 51 is a or isn't a prime number in the chat, in the comment. Next, we decompose 12, and when we decompose 12 with prime numbers, we get prime factors. And so this is a method to find prime factors. The next step, we decompose 72, and again we get prime factors. Now how about if they ask you in the exam to find all the factors of 12? So let's step back a moment and find all the factors of 12. Let's do it in this corner here. So we know 12 is equal to 1 times 12. So 1 and 12 would be factors of 12. And then we say 12 is also equal to, let's look at this. I would like you to pay attention to this here. All right? In fact, that looks ugly. Let's draw it nicely. Yep. Okay, so that's much better. Right. So I'm saying let's pay attention to the red box here. 2. So 2 times what equal to 12? And if you look here, you'll see 2 times 6 is equal to 12. Okay? Next, you have 3 here. 3 multiplied by what is equal to 12? Again, you can look right here. 3 times 4. Because 2 2's is 4. 4 times 3 will be 12. So you can go again. 12 is equal to what? 3 times 4. And again, 12 is equal to what? After 3 is what? 4. 4 times 3. And notice we are repeating ourselves. And because we are repeating ourselves, we will just strike this out. Alright? And we can stop here. So now we can write all the factors of 12 from this here. All the factors of 12. So all the factors of 12 will be what? 1, 2, 3, 4, 6, and 12. Alright, so there you go. If you want all the factors of 12, this is the method you use. Very, very good way to find factors of a number. This will be very, very useful to you when you do factorization. Alright? Because when you're asked to do factorization, you will have to be able to generate all the factors of a number. Alright? So this is your foundation to your CSEC as well as your IGCSE examination, factorization. Alright? Notice how far back I came, till into primary school work. Alright? So yes, you need that. You need to remember these methods to, so this is how much? We said this is 6, right? Good. Write that neatly. Good. Let's do all factors of 72. Similarly, again, we can highlight this nicely. There. We'll pay attention to this part. Now, right, so let's do this. So we can say 72 is equal to 1 times 72. And notice I'm doing this systematically. Then I'll go 2. 72 is equal to what? 2 times what? 2 times 36. Look, it's right here. So 36 is equal to 72. Then the 3. Do I have a 3? Yes, I have a 3 here. I have a 3 here. Alright, so 3 times what? This is 8, 3 is 24. 2 2's 4, 2's 8, 3 is 24. So this will be 3 times 24 equal to 72 again. Then again I can do, let's do the other one. After 3, do I have 4? Yes, look, I have 4 here. 2 times 2 will be 4. So the rest here is what now? Is 9 times 2 is 18. So it's 4 times 18. Okay, 4 times 18. So the next, that will be 72. After 4, do I have a 5? No, I don't have a 5. Do I have a 6? Yes, I have a 6. Look, I have a 6 here. 2 3's will be 6. So I can write 6 here. Times what? Times 4. 2 2's 4 times 3, which is 12. Alright, so that's 72. And again, after 6, 7. Do we have a 7 here? No, we don't have a 7. Do we have a 8? Yes, we do have a 8. Let me show you the 8. Look, 8 is here. 2 times 2 is 4. 2 is 8. So this is 8. 8 times what? 9. So this is 8 times 9. And this is 72. And notice what happens now. After 8, we'll have 9 times 8. 72. And what did we say? Now that we notice that we are repeating, we can just what? Cross this out and just write in all our factors. So all of our factors now, select from here, will be 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. And there you go. You generated all the factors of 72. Alright, so this is quite nice. Make sure you practice this method because you will find it very useful when you're doing what? Factorization. Alright, when you have to generate all the factors of a number. So next, we did multiples, we did factors, we did prime factors, we did find all the factors. How about finding the highest common factor? Now the highest common factor is quite similar. Let's take the same two numbers that we had there just now. We had 72 and 12. So let's find the highest common factor. We'd like to find the highest common factor of 12 and 72. And I'll do this quickly again as reinforcement. 12, 2, 6, oops, 2, 3, 3, 1. Let's do this here. 72. 2, 36, 2, 18, 2, 9, 3, 3, 3, 1. So reminder quickly, we had 2 times 2 times 3 is equal to 12, and we have here 2 times 2 times 2 times 3 times 3 equal to 72. And notice what happens here. You got a common factor here, and you got a common factor here. If you want, you can do this one here. So notice what? This is common factor. This is common factor. So the highest common factor is equal to common factor multiplied by common factor. And you can have more than 2. So in this case you only have 2 common factors, so you just multiply the common factors to get the highest common factor. So in this case will be 2 times 3, and it's equal to 6. Okay, 2 times 3 is equal to 6. Now this is a really good method to find highest common factor. Of course, you could have looked at the let's write back the fact, compare them here. You could have gone through this and say, look, 1 is common with 1, 2 is common with 2, 3 is common with 3, 4 is common, and then 6, and they don't have a 12. So here you let's put this in another color, and you're highlighting your common factor now. 6 is the highest common factor, right? I don't like this because you have to do all the factors, and then you have to do all the factors, and then you got to go manually and search for them and find it. Okay, that's one method. A better way to do it is to find the common factors, decompose the numbers the way I show you here. Decompose the numbers. When you finish decomposing the numbers, you identify the common factors and you multiply all the common factors, and the product of the prime of the common factors will give you what? The highest common factor. So how to find the highest common factor? The highest common factor is equal to the product of all common factors. All right, so this is your method. Well, how do you find highest common factor? You find the product of all the common factors. All right, and here you go. I show you a method on how to do this. Right, so that's that. Next, lowest common multiple. And again, mind you, this is a really good method. If you know this, you will be this will also help you in your exam, right? So please learn this. All right, so let's move on to lowest common multiple. Lowest common multiple, LCM. All right, let's look at lowest common multiples lowest common multiple of 12 and 72 again. And 72. We want the lowest common multiples of 12 and 72. How do we do that? We then decompose the numbers similar to what we do just now a moment ago. But this time, we decompose them together. 12, 72. And again, we use the prime numbers. I'll put back the prime numbers here to pick out from them. I got 2, 3, 5, 7, 11. Okay, so these are the prime numbers that we'll pick out from. So 2 into 12, 2 into 12 will be what? 6. 2 into 72 will be 36. And what other number? We can go with 2 again. 2 into 6 will be 3. 2 into 36 will be how much? 18. Now, can we do 2 again? Yes, we can do 2 because 18, we still have a factor of 2 in 18. So 2 into 3 can't go, and because it can't go, you'll put a 3, repeat the 3, and 2 into 18 will be 9. Now, you can't use back 2, but you can use 3. So 3 into 3 is 1, 3 into 9 will be 3. And again, notice you can do 3 again. So 3 into 3, 3 into 1 is 1, can't go. 3 into 3 is 1. And now how you find the answer here to this is quite simple. I suggest you multiply in this direction, upward, because it's easier to go up than to come down. You'll see why when you try it. So 3 3s would be 9, 9 2s, 18, 18 2s, 18 2s, 36. 36 times 2 will be what? 72. And so your LCM will equal to 72. Why am I showing you this? Because exam students, yes, you did this in your grade 4, grade 5, grade 6, whatever. But many times exam students, they know to find LCM, they know to find factors, but when they have large numbers, they get difficulties in finding the factors and the lowest common multiple. All right, here you have a method to practice and use to solve a reminder when you have to find. In fact, let me show you one just as a teaser, so that just to make sure that you know that, look, this is important. If you have a equation like this, let's put 24 here, and let's put 11x here. How do you factorize this? Quickly, you have to know all the factors of 24. I did, so I can just write it here quickly. 2, 3, 4, 6, 8, and 24, right? Of course, you got 1, 2. And you need to pick out which two numbers, when you multiply them, you get 24. If you multiply two numbers, you must get 24. And when you add the same two numbers, they must equal to 11. All right, which two numbers that multiplies to get 24 and you add to get 11? The two numbers will be 3 and 8. 3 8s, 3 times 8 will be 24, and 3 plus 8 will be 11. Okay, and so this becomes x squared plus 3x plus 8x plus 24, and this will be easy to factorize. Of course, I'll teach factorization in another video, but just to give you a little tease on it, why it is important that you learn to find all the factors of a number. All right, just for completeness, I will finish this off. X into x plus 3 plus 8 into x plus oops, plus 3, and so this becomes x plus 3 into x plus 8. And more, I'll do more videos on this, but just I know why I did this last piece, because many fifth formers, exam students, they tend to think that, oh, this LCM, this factor thing that I just show you, that's not important. They want to do higher stuff. Guys, I'm telling you, if you want to do the difficult stuff, you have to get your foundation correct. You cannot build a large building on a small foundation. All right, you have to get a solid foundation to build on. And so these foundation videos are very, very helpful. Um, with that in mind, I will invite you to like this video. Um, of course, subscribe to my channel. All right, and yes, subscribe to my channel, and I think I have a, that's this summary. Yes, I will just remind you to join with me. Search for high school at home. Sorry, they'll I have some videos on Facebook at High School at Home, and the YouTube channel is High School Mathematics in Simple Steps. Okay, High School Mathematics in Simple Steps. Please remember to subscribe. Please remember to like the video if you do like the video. And I also have classes, Zoom classes, and so on. There is a link. You can sign up for classes also. All right, guys, that's all. Take care, and see you in the next one. Bye.